Let's start, please. We are starting week 6. It means we're more than a third of the way through the semester. And we're going to just keep ramping up the pressure here, I guess. Let's do a little kind of review stuff and some discussion first. So for this assignment, I set it up as a Canvas Project Manager assignment. You don't have to use it, right? You can see on the assignment there's a direct link to a zip file that you can import into your Eclipse. But if you use CP/M to submit, there's 2 parts to the submission. One is the zip file of your code, and the other one is the short PDF describing bias in the automated reviews, just like a short paragraph. Canvas doesn't like you sort of doing multiple submissions, so if you use CP/M to submit, that counts as a submission, and then you can go to Canvas and submit your PDF, and that's all fine. But unless you know how to poke around a little bit more, you're only going to see the PDF as your submission, and you're going to be nervous about that. Your zip file is still there, and I believe you can see it, at least I can see it, like on the page, there's a little pull down that says submission on February 14th at 5:45 p.m. and I can click on it and see previous submissions, and you'll see both things there. And when we download your submissions, we see both of those things. It picks, for each type of thing, it picks like the most recent one. But don't panic if you're pretty sure you submitted, and I believe you can figure out how to double check where it is. Does anyone know from the student side how to look at all these multiple submissions? Like, am I just making stuff up, or anyone try this? Yeah.
In the app, if you go to submission, it usually shows you a list of your submissions.
In the app, at least, huh?
Yeah.
And I said, I think in the web page it might be a pull-down menu or something like that. Anyway, poke around a little bit more, get a little more familiar with the Canvas stuff. But don't be worried if you're not. Once you submit the PDF, if it looks like it overwrote the zip file, it's just added to it as a separate submission. But I know you probably want to reassure yourself, so do make sure both are there. Okay. So any questions on that? If you're having trouble with CP/M still, let's still poke at it. You know, I'll get started on it. Don't let that hold you up from the assignment. Download that zip file instead. But I'd still like to solve this for you and figure it out. So we need to find some time to spend a little time looking at this issue. Anything else kind of assignment related? Do the sort of the simple array stuff first, kind of get in the swing of things. And it's a pretty big jump up to the movie review thing. I mean, the complexity is a lot harder. And for those of you who've been putting this off to the sort of the end, you should try to get started a little earlier this time. And it's okay if you get stuck. It's okay if you get frustrated. That's part of the learning process in our view. But if you get stuck for a long time, try to email us and see if we can help you along a little bit, talk to the TAs and so on. Are we going to ask a question, or anyone? All right. The other thing, I did get a little feedback from the TAs about help hours. You have to have done enough to kind of know that something is wrong. You can't just sort of say, save me, and wave your hand at the screen. You know, you have to say, when I try this input, I get this result, and I'm not sure exactly why. I was expecting to count up to 10, and it counts up to 9. You know, you need a little specificity in there. And if you can't ask that kind of specific question, it means you are not thinking about this problem the right way yourself. And you need to train yourself to think a little more specifically about what's wrong, because you can't fix stuff just by typing in numbers and characters and code. You have to really dig into it. And so you have to force yourself to look at the details. Okay? And this assignment in particular is going to require that, because there's all these pieces that work together, and you have to kind of see how they fit together as a big picture, but those small parts also matter, and you have to really figure out how to make those small parts work. So when you run into problems with those, let us know. Okay, it's more complicated. It's going to cause some of you some troubles here, but that's not my goal. To make you sad. It's to make you think deeply about the issue here. And I want you to really dig into the problem and try to figure out what's going wrong. All right. This is sort of a random little topic that I keep meaning to squeeze in and I haven't. So you can make arrays of arrays in Java. So we've talked about making arrays, and typically, they have the form of the type of thing being held in the array, and then you give a square bracket notation, and you give the variable name, and then either make a new array or you initialize it with something, kind of thing. These elements, instead of being int, can be an int array, in which case you say the type of the array, the type of thing the element holds is an int array, and I want an array of those things. Okay? And in fact, you can keep going if you want. I can have an array of arrays of int arrays. And you can really cause yourself some trouble that way. So if you want to initialize it, you're allowed to initialize it with this. This is initializing a 3-element array, and each element is its own array. And so I can initialize them one at a time like that, build it up. And of course, typically when you start getting to be having complicated 2-dimensional arrays, you're not doing a lot of hand initializing because it's often a lot of data. Usually it's something computational that's filling that in. In that case, you would just say I want a new int array of int arrays. And anyway, it gets tricky trying to figure out what's going on here. You access it using square bracket notation. And so this first 2 says give me the second index into that big array. And then the third one says give me the 3rd element of that array I got out of there. Right? And so you have to sort of unbuild this thing piece by piece. Pull off a layer, and then look at the array that's left, and then go dive into that array to figure out what's going on. We aren't really messing with arrays of arrays yet, but I just wanted you to kind of be aware of the possibility for now, and at some point we'll probably use those a little more interestingly. Another thing is that if I were to say this, what is this going to be initialized with? A bunch of nulls, right? Because arrays are objects. And so they're not really any value, any place to store values in there. And I would have to make a new int array of size 4 put into the first location, and a new int array of size 4 to put in the second location, and so on. So again, we'll talk more about this, but the main thing is I want to show that you can build these more complicated array structures. There's no restriction on what array you can hold. So it can hold strings, it can hold ints, it can hold doubles, it can also hold arrays. And that's the notation for it. Okay, last lecture we got into what I thought was sort of some interesting subtleties with working with arrays. The idea of arrays are really a reference to an array. And I want to have some Kahoot questions asking about this. So let me start up a Kahoot quiz and get your devices out. So our Kahoot pin is 7831566. All right, so log in at kahoot.it. If you need a device, you can somehow grab one of these. I keep charging them and bringing them. No one wants them. It's very sad to me. Second to finish logging in. So in this question, I'm going to give you a little code within an array, and I want you to tell me, I have a print line at the end, I want you to tell me what's going to come out at the end, okay? So look at the code, and make sure you're tracking which variable is being called where, and let's see how it goes. All right, so before we actually start the Kahoot side, I'm going to bring up the first question. So notice I'm creating 2 int arrays, initializing with values, assigning things to various locations. What comes out the end here? All right. And Again, talk to your neighbor about it. It's not any, I'll like you to help each other a little bit. 60 seconds. Five seconds. All right, so pretty good, but not perfect. This was actually a trick question in that it wasn't a trick. Okay, so let's think about this. When you see a declaration of an array variable, I want you to keep in mind that that variable is referencing an object on the heap somewhere. So this object in some sense is independent of this name, but this thing knows about that object. So we have our values array, values reference that is pointing to this object that holds 0, 1, 2, 3. We have our numbers array that is pointing to an object that holds 5, 6, 7, 8. And then I say values 0, values at index 0, equals number 0. And again, the way you evaluate this statement is you say, okay, what does this evaluate to? It goes, looks at the 0th index of numbers, and that becomes a 5, the value 5, right? And that gets assigned to value 0. That's fine. We're changing the actual value stored in the array, right? Then I say values of 0 equals -1. That's pretty direct, -1. Notice these two spots aren't connected in any way, right? Just because I assigned this value to this location doesn't mean, that's not a, this thing here doesn't evaluate to a reference. Numbers 0 is a primitive, an integer. And so it actually just evaluates to a pure number in this case. It's not a reference to number 5. It is just the actual value number 5. And so when I change this location here to number 1, it doesn't affect this location here. And then, of course, maybe what seems a little funny here is that I'm printing out number 0. And number 0 is at 5 there. Okay? So there actually wasn't very much tricky here, except that I've been talking about all this sort of shared stuff and references, and maybe you sort of fell into that trap a little bit. Question on that? So that's the model. You have to be able to draw these kind of pictures on paper when you're working through these problems to make sure you're kind of doing the right thing. All right, here's another one. Slightly different code. So let's see what comes out at the end on this one. Discuss your thinking with your neighbor. Ten seconds.
So you want to say 0?
All right, a little more trouble on this question. Only half of you got it right. So, we have our values reference to an int array. We have our numbers reference to an int array. Then I say numbers equals values. This is the big question. What does this mean? What are the semantics of this, right? What does it do? It says, take the reference that's stored in values and assign that to numbers. Well, the reference in values points to this object here. And at this point, numbers also points to that thing. That's what it means to assign the reference, right? That this thing references that object. Now numbers references that same object. And then the next line, I said, values 0 equals -5. All right, let's find the 0 index spot for values. That becomes -5. And then I want to access the 0 spot of numbers. Well, the 0 spot of numbers is this -5, so it prints out -5. Okay, question?
So that changed the reference, that line of code. What would that code look like if you were just changing numbers to be the value of values and not actually changing the reference to values?
Well, the question is how you do that, right?
Right, that's, I'm just curious what the difference would.
Okay, let's, so there are methods that copy the values over.
Yeah.
And you're using that on the assignment? No, maybe you're not. At one point you were going to, but let's look at another question, maybe, that maybe illuminate this a little bit more. So I think we briefly talked about array copy in class. I showed that as a way of, and this clone method basically acts like array copy. Okay, so what would this do?
And it doesn't copy the fact that value of 0 is equal to 5. So instead, it's going to keep the initial value of values of 0 versus 0. Can you remind me what array copies do? It just copies the array from another array, right?
It sounds like it doesn't just point, it actually grabs those values and flips them down.
But, yeah, and because values changes its value, numbers does not.
7 seconds.
So it's like a difference between the clones, I guess.
Yeah, I think.
All right, a little better on this one. Let's see what happened here. Okay, so we have our two variables that reference int arrays that we've made. And then I say this values clone, numbers equals values clone. And again, the question is, what exactly does values clone do? I know you haven't had a lot of experience with it. That's a little bit unfair, but this says take this int array and make a new int array of that size with the values copied over. So what really happens here is that there's a new object on the heap that holds, still 0 here, it holds 0, 1, 2, 3. And I say, make numbers reference that object, right? That's what assignment means in this case. So this reference now goes to this object here. That's a distinct object from the original array. That's what the clone does, and also what array copy does. And these values are copied over one at a time. So the next time when I say value 0 equals -5, that changes values one, but not this copied one, because that's a different spot in memory. And so when I print out number 0, it prints out the 0 here.
Wait, no, but 0 is considered wrong as.
Yeah, we
Did I have the wrong answer? Did I put the wrong answer in there?
Yeah. So we were right, but the answer was wrong.
Oh, sorry. I just saw it doesn't tell me whether people are right or wrong, it just says how many answered each question kind of thing, so a lot of you did better than you thought. I must have just copied that slide and then it,
How am I supposed to like improve?
What did I say was the right answer? Oh, -5 was the right answer?
No, well, it was considered the right answer. 0 is the right
Well,
answer.
0 is the correct answer. I don't know what Kahoot's telling you, I guess. Kahoot's doing something it shouldn't. I'll fix that. Anyway, you should print out that 0 here, right?
Cool.
Sorry that your scores are ruined.
If we were to put numbers equal values.clone underneath values 0 equals -5, would the right answer be -5 then?
Okay, so the question is if I put that clone here,
Yeah.
well, this array would be different. So when you clone it, that -5 would be in there, and it would copy the -5 down into here.
Okay.
Right. Okay, so we're really just probing your understanding here. Strings are objects, right? So we're going to come back to little strings here. So what would the output be here? Now I've lost all confidence in my marking the right answer on Kahoot, so I'm all nervous what it's going to tell you. We'll see. I got to make some new arrays here.
I want to say it's circle.
Yeah, that's what I said.
Wait. No. Actually, it's other. Because it doesn't specify that it wants it at 0, it just specifies between whatever. So if anything, wait. No. Actually, no. Because letter is 0. Actually, I think I'm wrong. I forgot what I previously said.
We'll see if Kahoot's wrong.
Yeah. It wouldn't be AF, then unless, yeah, no.
All right, still kind of mixed.
Correct?
So this is a little tricky because this is the mental model we sort of have of an array of strings. In reality, though, what's kind of going on is that in the heap, well, the strings, not 100% sure what's going on with strings, but with objects, this array holds an array of references to strings. All right, that's the way to think about it, right? It's not holding the value directly. If it's an array of objects, it holds an array of references to those objects that are also created somewhere on the heap. And I'm going to say that letter, when I say letter equals letter 0, it says, okay, where is this referencing? Well, it's referencing that A right there, right? So it's pointing to A. And then I say letter 0 equals F. Well, that makes a new object on the heap in F. And this reference no longer goes to A. It goes to F. And so when I print out letter is still pointing to A. Okay? So arrays of primitives hold the values in them. Arrays of objects, strings, scanners, other arrays, other kind of objects we'll learn about, are really references to those objects. And you just have to be careful about what that means. And it means that, again, it doesn't really have any meaning here. I mean, it's nothing too tricky unless you sort of fooled yourself, basically, again. This wasn't a trick question. It was just sort of a chance to get confused. But this is the right model for how you should think about it. And it's very important that you keep thinking about things in a consistent way. This is all very simple stuff, but you have to be like rock solid in how you apply these rules, right? You can't just sort of make up something. You have to apply it the same way.
So is there anything that an array can hold where if you reference it at one time, that when you change that array, it will change what you reference? Does that make sense?
Yeah. So
you
maybe we'll see something like that. Okay. Hold off on that a second. Yeah.
So it would print out the letter A, it wouldn't print out the reference A, like the reference address?
Because now strings know how to print themselves out like sort of automatically.
Okay.
Right? Like when I say print a string, it prints out the string. Strings are a little bit funny in Java, right? That they're like halfway a primitive and halfway an object. And because they're used a lot, and it'd be weird to have to say like toString of a string, right? Like it's already a string, so I don't know why I have to do that. So anyway, yeah, it's a little bit strange. That's a good thought, though. I mean, it made me nervous for a second. Like, ooh, maybe it does print out a reference here, right? So, yeah. Okay, now our grand finale. Okay, I'm making an array of arrays and doing stuff to it. I'll give you a second before I hit the start on this one. More complicated.
If anything, it would print out the original array. Because grid
All right, I'm gonna start.
changes, but grid 1 does not. I feel like it would be 1 and 2, but it's not. The value between the circle is. It's 0, 0, so then it would print out the x and y basically, so it would be 1 and 2, but that's not really how that's just either. How many more seconds? Oh, how many more seconds? Sorry.
20 seconds.
Thank you.
Make sure, sometimes it's grid 2.
Oh, no, it's the first one or the first one.
Okay, pay attention to which one.
So it would be 1.
7 seconds, quick! Push the button! Oh, very few of you got it right. All right, this is good practice. My kids started playing HQ Trivia. Do you guys know that? It's like online quiz show thing, like on app. And you get like 10 seconds to answer a question, so go practice for that. All right, so here's grid 2. And it's that nice clone thing, right? So what does clone do? Someone tell me again what clone does.
It
What's
generates a copy?
It what?
It generates a copy?
Yeah, but you maybe break that into like 2 steps or something like that. What do you think? What is it?
It creates a new array.
And copies the values.
Copies the values of the original array into the new one.
All right, so we're making a new array of size 3. All right? And it copies the values from grid over. So the first place in grid is a reference to that array. The second place in this is a reference to that array. The third place is a reference to that array. Those are the values in there. The value is a reference to an object in the heap. Okay? It's not the array itself, it's a reference. So we're copying the reference. Because what clone does is makes an array the same size as the thing we're copying and fills it with the same values. Now I say set grid 2, 0, 0 to be -5. All right, grid 2, 0, 0 is -5. And then I print out grid 0, 0, which is now -5. All right?
Could you do like a deep clone?
So there's something called a deep clone, and that kind of goes through all the levels and tries to copy values where possible. So sometimes it's called a deep copy, a shallow copy. Shallow copy is when you use copy and reference. A deep copy is when you're actually replicating the values held in that thing. And in this case, this clone thing is sort of halfway between a shallow and a deep copy because it's copying, it's making a new top level, but the things inside it are still just reference values that are copied over, right? So yeah.
So the fact that grid 2 turns into -5 changes grid 1's?
So the fact that grid 2 changed the array stored inside it, since that is also referenced by grid 1, it references the same object here. So it looks like the same thing.
So two questions ago we did values.clone and it didn't have that same behavior.
That's because the thing inside it was a pure primitive value, not a reference.
Oh.
All right, so that's the tricky thing. Java has primitives, and those values are like right there. They're not referenced through a layer of indirection. Okay, so these things are making a copy of that value, a 0 to a 0, a 1 to a 1. In this case, this thing is really an array of references to other arrays, and those references get, the value of that reference gets copied over. So this is subtle stuff and can trip you up like all the time, right? And you're going to write some code sometimes that things are changing each other and you don't know why, and it's because you have sort of a vague sense of when things are a reference and when they're primitive and when they're actually copying and when they're making a new thing, and this is hard to debug. So the more you can kind of focus in on this, if you can understand this one, you're golden for the rest of your life in Java, basically, right? This is basically as bad as it gets with a reference deal.
So we have to worry about it not doing a deep copy if it's an object or something bigger than primitive?
So if it is an object and you want an independent thing, you should do a deep copy. There's some deep clone, or I can't remember what it's called, array deep copy or something like that. And if it's a primitive, you don't have to worry about it as much.
Going back to the one that we had with the string, how come when a string, we're changing the value of f in that string array? Why does it create a new location with f rather than changing the value?
So strings are objects. Every object is created on its own space in the heap.
Right?
And so if I make an f, it has to go somewhere. And
So we don't ever overwrite the heap data. If it's a new information, we always make a new home for it.
yeah, this is a new object. But basically, again, strings are funny. This is technically a new string initialized to be f, right? And when you see that new thing, that means it's created somewhere on the heap. String has these shortcuts that makes it more confusing. So this looks like a primitive in some ways, but it really is an object.
So whenever we're changing a value of an object, we're literally just creating a new object on the heap and changing our reference to it.
As long as there's a new or something that looks like an initialization somewhere, then it creates a new object on the heap somewhere. All right. And the problem is like here, if I had done what? If I'd set letter 0 to be f first, it would make that be an f, and then I would copy that f out of there with an assignment, but I did the order kind of funny here. All right. So I would suggest you really need to go through these and see if you can reproduce them, right? This is the correct, these are designed to make you think the correct way about arrays and references, and if you can't think about it correctly, then you've got some problems you need to overcome. So we can help you with that, but you need to force yourself to think this through very carefully.
So in this example, when you're cloning the primitives, it doesn't change the other reference, but then we go higher to like the grid arrays.
So when you have primitives, they literally are like values in the array kind of thing. It's not a reference to, it's not a reference to some 3 object or something like that, right? It really is kind of like right there, the value. So the problem is, in Java, there's 2 models for how this works, right? One is the primitive model, where the array holds the values themselves, and then there's the object model, where it holds references to the objects. And they behave in different ways, basically. I mean, they don't really. We're still copying values, but those values are references instead of the objects, and so they're not independent, you know? It makes it hard to puzzle through it.
Yeah.
So really work on this to get the, I mean, again, the way you think about things is very important in this stuff, right? You can't just kind of muddle your way through. There's very simple rules. Make the array, copy the values, right? Just force yourself to apply that like a robot to the problems and you'll get the right answer. But if you start saying like, oh, there's a 1 and a 2 in there, you're going to run into more trouble. Okay, so I think that's a very important topic and I want you to really get good at that. But let's talk about something a little different now. So let's talk about searching again one more time. So if I have some array of values, and I want to find out if another value, a key value, is in that array, I want to search for some value like 3. How am I going to do this? What's the basic, I mean, this is a pattern we've seen, right? How would I write code that does this? What kind of constructs would I use? A for loop. I'm going to loop over each index in this array. I'm going to pull out, so this is kind of write I'll just say for stuff I want, make an index. In there, I'm going to say if, this is some key value, if key is equal to values at index, if that's true, that this number here is equal to the number in here, what do I want to do at this point? Yeah, I found it, right? So I'm going to return true. If it's not equal to 3, what do I want to do? Someone raise your hand. It's not? What's that? Okay. There's nothing else I really want to do in here, so I could continue, but I don't have any more statements in my loop, basically.
I think you probably meant continue looping.
Oh, continue looping? Yeah.
Until you reach search.
What I want to make sure is, some people, again, want to write else return false here. But again, just because like the first element you look at is not 3 doesn't mean we're done. We don't know yet whether or not it's in the array. So we do our loop. We finish our loop. We can finally return false once we've checked every element in the array, right? So in practice, again, you see this. You're like, is 3 equal to 1? No. Is 2 equal to 1? 3? Is 1 equal to 3? I don't know. 3 equal to 1? No. Is 3 equal to 2? No. Is 3 equal to 3? Yes. I'm done. I found it, right? Return true at this point. And once I hit that return true, I'm done with that whole method, right? It doesn't try to do anything more. What happens if I'm looking for 5 here? Is 5 equal to 1? No. Is 5 equal to 2? No. Is 5 equal to 3? No. Is 5 equal to 4? No. We're out of elements. The loop finishes. And we're going to return false. We did not find it. We looked at every element, right? If it's not in any place in the array, then it's not there. And we can't say that until we looked at everything. All right, so here's some code. This is called sequential search because you look at the elements one at a time. Look here, look here, look here, look here. I have a loop because I use my big current index variable. It doesn't fit in one line. I split it into multiple lines, but it means the same as Java, right? We can add new lines in the code if we want to. We're going against the length of the vals, and we keep checking to see if the value we're looking at is the same as the key, and we're not, we return false. All right, so that basic pattern is pretty easy. If I wanted to say where I found it again, I would return current index here, and probably return some special value like -1 down here if I didn't find it, right? So I can return where I found it in the array, rather than whether it's there or not. And that also has its own use because you can use that later to like do stuff to it. All right. So let's think a little bit about the complexity of this. How many items does our algorithm, our code, have to look at to see whether or not that key value is in the array? So what's the best scenario for this? How many times would I have to look in the array and say, is this the thing I'm looking for? What's the best case? once, right? It's like the beginning of the array. If I'm looking for 1, I say, is this equal to 1? Yes. I've looked at one item, right? So that's super fast. It just looks at one thing. What's the worst case? All of them. Sorry, I heard a lot of people say all of them. When does the worst case happen? When it's not there, you have to look at every item in the array to decide that it's not in there, right? You can't give up halfway and say, I'm bored, I'm just going to stop.
Technically, it would be in the last one.
Right.
Still.
But I mean, if it's the last one, then it's the almost worst case. But you still have to look at it, I
You have
guess.
to look at it, right?
Yeah, so I guess that's true too. But in general, we think of it like not finding it means you look at every item for sure, right? So, it's the first location, it's 1. If it's the worst case, we say it's the length of the array, right? And a lot of times we say it takes, like, for an array of length n, we're just using some unknown length, some variable, like in algebra. It takes n steps, n repetitions of the loop to decide that it's not there. Now, there's a special notation we use in CS to sort of talk about this cost, this execution time, sometimes memory use, other things, but often execution time. And it's called big O notation. I just want to briefly talk about that. And it's about, it's for describing the worst case behavior. We really only care about the worst case behavior of an algorithm because it might happen, and then if it's really bad, we're in trouble. So we want to know what the worst case is. And if you think about different algorithms, they have different behaviors. So let's say I have an algorithm that just says, give me the first item in the array. So I return array item 0, right? It's some int array of size 100 or something like that. Well, if I return the first item at index 0, that only takes one step. I'm not looping over it. I'm just saying, give me that value, right? So it happens what's called constant time. Some algorithms take as many items as there are in the data. So if my array is a certain length, I might have to loop over all of them. This sequential search is an example of that. If I have 100 items in the array, it might take me 100 steps to decide it's not in there. If I have 1,000,000 items in the array, it might take me 1,000,000 steps to decide it's not in there. So it grows at the same rate as the input length does. Some do worse than this. So let's say I have 2 arrays. And I want to see how many of these values are in this array. I'm going to count up how many times does a value here show up over here. All right? How would you solve this problem? Don't tell me like, wow, blah, blah, blah. Just say how you kind of by hand, how would you solve this problem? I want to count up how many times any of these values shows up in this array. How would you do it? You see it? You wouldn't do it? You want to do it even if I ask you nicely?
See if it's scope first.
Okay, so they have to know about each other, so they're in the same scope. And again, this is not a problem that you just say you have to break it into steps, right? Let's say you're in a grocery store, you have your list, and you have your cart full of groceries, and you want to figure out if you've gotten everything on the list. And you forgot to X them off as you got them, right? How would you start doing that?
For each number in the first array, you look at all the numbers in the second array and see if they match up.
Okay, yeah. Go back to my grocery store, you look at bananas on your list, and you go through all your things looking for bananas. And how many items are you looking in the cart to make sure you have bananas or not? Like, what if you didn't have bananas? How many items would you have to look at? All of them, right? So yeah, same kind of thing here. For this item, we have to look at all these items here, right? For this item, well, we only have to look at this one, but worst case, we have to look at all of them. This one, look at all of them. This one, look at all of them. So, how many times do I have to look in this array overall in this particular case? I had to look at them 4 times, another 4, another 4, and another 4, right? So 16 times total, or really 4 squared, right? If there was 5 in each of these, it would be 5 squared. 6 in each of these, it would be 6 squared. So the time would grow pretty fast. It would go 16, 25, 36, 100 eventually. Let's say you skipped our ethical hacking class, and you're trying to break my Kahoot password. And my password is 5 characters long. how many different passwords do you have to try to crack my password?
Do you have letters and numbers?
Well, let's say there's only letters. How many letters are there? 26 letters. If the password were 1 character long, how many different things would I have to try? 26, right? And if it's 2 characters, how many would I have to try?
26 squared.
I have to try 26 in that first position, and then 26 in the second position, and those combinations multiply each other, right? If there's 3 characters long, another 26. Oh yeah, okay. And so on. So for 5, it would be 26 times 26 times 26 times 26. And that is the same as 5 times 26 power. Different things, right? Let's say my password was 10 long. It would be 10 to 26 power, right? I know, hey, maybe I got this backwards. 26 power. Is that backwards? Yeah. Yeah. All right, so that's the wrong example then. Why were they thinking this? I was all excited about it. Oh yeah, so okay. That's not the example I wanted. I'll have to go back and think about that. But it's still bad, right? Okay, so in big O notation, we're not interested in all these basic numbers. So for some data of length n, usually you can describe the execution times in terms of some kind of equation, like 4n plus 10 or something like that. You sort of count up all the little things you're doing. And that's too hard for us to kind of like keep track of, so we want to strip it down to the bare essentials. So the rule is, you take some equation, and you take the one that grows the fastest. So in this case, n to the 4th power grows faster than n squared, which grows faster than 2. As n grows, the 1 to the 4th power gets bigger, bigger, faster. So we take that term. Then we just get rid of anything that like scales it, like multiplies it by 6. And we just say this is an n to the 4th algorithm. And we describe it by saying this is a big O of n to the 4th. So basically we're saying this algorithm grows as n gets bigger, it grows as the 4th power of n. And so if this number gets big, your algorithm gets bad pretty fast. Now back to our algorithms. If you take one step, that returns 0 thing, then it's a big O of 1, constant time. Our sequential search is big O of n. It grows the same rate as the data grows. If it's the one that looks for the replicated values in there, it grows n squared. And oh, I did do it right, I guess, here. That's still not what I want. That's not exponential anyway. That's wrong, my description of that one. But you can get even worse kind of algorithms. I'll find a better example of what I was looking for later. So this notation sort of is a simple way of giving a rule of thumb of sort of how complicated an algorithm is. All right, let's see. I was going to shift back to search, but I think 2 minutes is not enough time to talk about the next step, so we will stop here and continue this in the lab and on Wednesday.